Hi, this is Terry, and what we're going to do is work on relevant costing. So we're using Transparency Master 12.1, and the first thing that we're going to do is identify what a relevant cost or benefit is, and then we're going to see that one concept applied to drop or retain a segment, make or buy, utilization of scarce resource, special order, and joint product. So let's move down. And the first thing is we have to separate what a relevant cost is. And the big issue here is that you need to understand that we're talking about for decision-making purposes only. The first definition then is a relevant cost or a benefit is a cost or benefit that differs in total between alternatives. Any cost or benefit that does not differ between the alternative is irrelevant and can be ignored. For example, if I'm trying to decide which is a better deal to go work at job A or job B, and job A is 60 miles in one direction and job B is 60 miles in another direction, the cost of driving there is not relevant because it's present in both situations. But if I'm going to work on a job that's 60 miles away or work from my home, then as part of deciding whether or not this is a good deal, I would include gasoline and wear and tear, oil changes, etc. So all the cost of operating a vehicle would go into, well, we don't want to do that. All the other costs would go into that job where I'm driving, but would not be included in the job where I'm going to work from home. So the idea is that these costs are avoidable. They can be eliminated in whole or in part by choosing one alternative. So avoidable costs are relevant, and that's a key issue. There are two costs that are never relevant to a decision, and that is sunk costs, so a cost which is where you've already spent the money, so no decision today will change the fact that you have already spent the money, such as buying tickets to go to a concert. And then something comes up and says, would you like to go to a wedding? If you can't sell those tickets off, they're not relevant to the decision, because if you go to the concert, you're going to pay for the tickets. If you go to the wedding and can't sell the concert tickets, then it's not relevant, because either way the tickets are used up. All right, so now that we've got these definitions, let's go down and look at a couple examples. Our first example is there is a company that makes watches, and if we look at their income statement, they have sales of $500,000, their variable costs are $200,000, contribution $300,000. They have all these fixed expenses, and they end up having a net loss. And the issue here is that these all of these expenses here, all these fixed expenses right here, some of them are not avoidable. So in other words, they'll be present whether we make them or don't make them. So for example, let's undo that here. For example, the factory overhead. That is an allocated cost. So if our company or if our division does not pick up that $60,000, it doesn't go away. That's property taxes, or that's insurance on all of the factories, whatever it is. So just because we quit making the watches doesn't mean it goes away. It's like you saying that if you're not going to drive a car, then you don't have to make a car payment. It just doesn't work that way. What we can do is get rid of the salary of a product manager, because if we aren't going to make the watches, then we don't need the manager. The equipment, same deal. That whether we use the equipment or not, we still have to depreciate it. We can get rid of the product advertising, and we can rent out the factory space or just not rent it anymore. So that would be avoidable. And then we have this $30,000 in general administrative expenses. Again, that's the president running the company. The president running the company, and those expenses aren't going to go away. So this handout does approach number one. I don't think that's as easy to follow, so I always use approach number two that just puts the two income statements side by side. So if we have the original data here, we see that we have a $100,000 loss. If we quit making the watches, we'll have no revenue, but then we'll have no variable expenses and ultimately no contribution margin. But if you look at the factory overhead, we're still going to have that. We're still going to have the depreciation, and we're still going to have the general administrative expense. So we're going to lose $140,000. So if we don't make the watches, we lose $140,000. If we continue to make the watch, now we're only going to lose $100,000. And so it's better off to keep making the watches. So prior to this chapter, you look at this and you'd say, oh, you're losing $100,000, quit making them. That's why we have this chapter. Is that's not necessarily true. You have to look at what costs are avoidable for decision-making purposes. Let's move on then to make or buy. Here's another situation where a company is making a part, and right now it's $30. That's how much it costs them to make it. Then they've got an outside supplier, so let's use the highlighter a little bit here. We got the outside supplier that's going to do this for $25. That's going to make all the parts that we need. So the question is, should we make the part and spend $30, or should we buy the part and spend $25? And again, you would think that the answer is pretty simple. If we can buy it for $25, let's do that. But that's not the case, because we've got $3 of depreciation that we're going to have to, we're going to have to depreciate it whether we use it or not. And we've got $10 here in factory overhead that whether we make it or not, that overhead, that property insurance, taxes, whatever it is still going to be there. So if we move on and look at the two side by side, if we have 20,000 units and we're going to buy them for $25 a unit, we're just going to spend $500,000. If we make the product, if we make this part, then if we're going to make 20,000 units, and it was $9, do you remember the numbers from up above here? 9, 5, 1, 3, 2, 10. So we've got $9 per unit times 20,000. We've got $5 per unit times 20,000. Then we've got $1 per unit times 20,000. The depreciation is not relevant because if it's present in both situations, we leave it out. The supervisor's salary is relevant because we're only going to have all of these, the direct material, the direct labor, the variable overhead, and the supervisor's salary. We're only going to have those if we make the part. But that factory overhead, again, is not relevant. So the issue becomes, for decision-making purposes, do we spend $500,000 buying it from somebody else, or do we make it at a real cost to us of $340,000? So the answer is we're going to make it. Let's see this happen again. And this is on special orders. So the Jamestown Candle Workers received a request from a foundation. They want 800 candles to light up a room. And the sales will have no effect on the company's regular outside sales. So this is a unique situation where it's not going to steal any other sales. A similar candle that they sell now is $3.95. And its unit product cost is $2.30. So $1.35 materials, labor, and manufacturing overhead. But of this manufacturing overhead, and let's go back to our highlighter again, of this manufacturing overhead, ka-ching, I just did the wrong one, sorry. Control Z, and let's try this one more time. There we go. then that of that 80 cents, 5 cents of that is variable and 75 cents it represents fixed. So the issue here is the fixed costs are not going to go away. The only costs that would be relevant out of that manufacturing overhead would be the nickel. In addition to this, then they have to buy a mold that's got the foundation's logo inscribed on the inside, which is $800. And then an additional feature they want is to add a thread, gold-like thread to the wick, which is going to cost 20 cents. And they're saying they only want to pay $2.95 when up here that same candle they normally sell for $3.95. So the question is, should they make it? So we have to run the numbers. So here are the numbers. If we're going to sell this candle for $2.95 and they want 800 candles, the inflow of cash is going to be $23.60. The direct materials for candle, $1.35 times 800, 1,080. 15 cents times 800 is $1.20. Then only a nickel is relevant for decision making, because the other 75 cents in fixed expenses are going to happen whether we make the candle or not. And then the special wick will add 20 cents. So if you look at our revenue coming in, we look at the fact that we're going to have $2,200 going out, the variable cost plus the special cost of the mold. Then $2,200 is going out, $23.60 is coming in. So yes, we would make this candle and we would still profit $160. The utilization of a scarce resource, you got to watch these numbers for this to make sense. So the setup of the problem is, if you don't have enough capacity to make everything you want, if you don't have all the chocolate you need to make a candy, or you don't have all the machine time that you need to bake something, or in a factory setting, a lathe, then anything that means that you've got to plan what you do, it becomes a constraint. And if it's a machine, then it's called a bottleneck. So the issue becomes that the fixed expenses typically are not the problem, because you've got all the machinery there, you're going to pay the depreciation, etc. It's just how you use it. So the way to look at this, and what this part of the chapter is about, is you need to maximize your contribution margin. So if we look at some data here, and we see that our selling price is 60 for product X, product Y is 50, the variable costs are 36 and 35. If we did not have a constrained resource, right, if that didn't exist, then what we'd want to do is sell as much of X as we can, because it maximizes the contribution margin. But here's the problem. Machine N34 can't run long enough to satisfy the demand. The machine can only run for 2,400 minutes a week. So if we were going to take 2,000 demand for product X, and it each takes a minute, that'd be 2,000 minutes. And if we were going to make all of Y, and our demand's 2,200, and it takes a half a minute, we'd need another 1,100 minutes. So we would need 3,100 minutes, but what's available to us is 2,400. So the issue again is we need to maximize contribution margin per unit of scarce resource, and our scarce resource is machine time. So what we want to do is look at how much money do we make per minute. So if X up here takes 1 minute and gives us 24, we're getting $24 a minute. Y gives us $15, but that's per half minute. So that's $30 per full minute. So the better deal for us is to make all of Y, then make X. All right, so let's move down and look at the rest of this. So let's look at these numbers and see if this makes sense. The total time available is 2,400 minutes, right? Then if we make all of Y, which was 2,200 units, they each take a half a minute. Now we've got 1,100 minutes out of that 24 that we've used up. That'll leave us 1,300 minutes left, and since product X takes 1 minute per unit, now even though we had demand for 2,000 units, we only have enough machine time to make 1,300. So if we multiply 1,300 times the contribution of $24, we get 31,200. 2,200 of Y times 15 is 3,300. We get 64,000. And I'm going to try and do some inking here, and I'm not sure whether or not I can do it. I may have to try something different, so give me a second here. Alright, this is going to be a little bit funky, but this is the only way I can do it because I can't get the inking to work in Word. So I brought up PowerPoint, and now I can do some inking and show you. I'm going to take these numbers from below and say, what if we didn't do it this way? What if we did it the old-fashioned way that we did 24? So we would have done 2,000, if I can draw with the mouse here, we would have made 2,000 units at $24 per unit, would have made then $48,000. Would you agree? If we use 2,000 minutes out of our total minutes that were available, and what were the total minutes available? 2,400, right? So now we'd have 400 minutes left, but for product Y, we can make 2 units per minute because it only takes half a minute. So $800 times 15, right, is now going to be 0, 0, 40, 800, boom, 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 and I need a little more room. Oh, I'm out of room. I don't know, maybe it'll, oh yeah, it'll draw down here. All right, so then that's another 12,000. And if we take the 12,000 and the 48 and add those together, we make 60,000. But now that we understand the concept of scarce resource and maximizing contribution margin, the deal is we just made our company $4,200 extra dollars because we understand this concept. Okay? Now we're going to take the same concept with joint product costs, and I'm going to try this side by side and see if this goes any better. But what we're starting out with here is we got a tree. And with that tree, what we're going to do is cut it down, and we're going to divide that or process that into 2 identifiable products. So one product would be lumber, and the other product would be the bark and all the scraps that we could use for mulch, bark, and mulch that we would use to go around bushes and gardening. And the question that we're trying to answer in this chapter is, should we process this further into something, I think it's called cove base, or what's another term for that? The trim that goes around the top of rooms, so whatever that's called. The other thing is, should we take all that bark and compress it under high pressure and make what's called presto logs that you see at Christmas time, where you put them in your fireplace and they burn for 4 hours and they sparkle and they do all that kind of stuff. All right? So we've got this trim, whatever it's called, and this lumber, and the question is, should we process further? And so here's the deal. We can take a look at it. The answer is if the additional revenue, so if the incremental INC period revenue is greater than the additional or incremental, sorry, it's the best I can do with a mouse, expense, then the answer is do it. So let's see how this works over here with some numbers. So what we're going to do at the split off point for the lumber is we're going to have $140. If we process it further, we can get $270. So what it's saying is we can pick up an extra $130 if we process this further. If it costs us $50 to process further, then the answer, or the question is it worth spending $50 to make $130? And the answer is yes, so we would process this further. To do this then with the scrap, we look at the scrap, and the scrap at the split off point is $5. If we sell it for bark, we get $20. So we're going to pick up an extra additional $15, but it's going to cost us $4 to press that together into logs. So the question is it worth spending $4 to make 15? The answer is yes. So both of them we would process further. Now, what do we do about these joint allocated costs? So we've got, what do we got? We got $200 in costs right here, right? Will this highlight? So we've got $200, home, highlighter. We got $200 in costs. That would be the same over here as this point. That to cut this tree down, we spent $200. And what your book tells you is these do not go into the decision-making process because, and let's change color of pens, because we would have spent that money to get lumber and bark no matter what. And what we're trying to decide is, should we sell at this split-off point or process further? That's what the chapter's about. Sell or process further. And we just proved that for both of them, processing further is the answer. I'd like to give you one more example and use this cow as this sell or process further concept that we've been talking about. So let's go turn the inking on and choose the pen and make sure it's thick enough and it's red. All right, so when you take a cow and the poor guy loses his head and you split him lengthwise down, from top to bottom, that becomes the left and the right half. Then you need to split the cow between the front half and the back half, and that's done right here. And the issue is you cut between the 12th and the 13th rib, because every cow has 13 ribs. To know where to cut this piece off, whoops, my mouse isn't cooperating here, then that's between the 5th and the 6th rib. So that gives us a total of 7 ribs for our prime rib. So this big chunk of meat here is called prime rib. And if we looked at this from kind of a side view, and let's see if I can draw it here. So it's kind of like this. Then there's this great big eye of meat in here, and then there's this little flap of meat that's kind of hiding. And the first thing you do then is you measure 10 inches here, and this is called the chine bone, and then you just cut that off. So when you do that, and then loosen the meat away from the backbone and loosen the meat away from the rib bones, then that's called a 103. When we turn around and take this piece of meat out, so let's see if this eraser will let me just erase, small erase. Do you think it will? So we're going to just erase this. So if this meat is taken off and this is now gone, right? There we go. And then we measure that we have 2 inches. So turn our pen back on, and our thickness I think should be good. If not, we'll make it good. And then we measure that this is 2 inches, and if there's anything extra we cut that off, then that's called a 109. If we take this bone away, so take this bone away and take this bone away and take the fat away, and ultimately then what we have left is this big chunk of meat with this 2-inch tail. So let's darken in the tail so it shows up. Then that's called a 2-inch lip on. So now there's no more bone and no more fat across the top. So should we try and erase it? Let's see if we can. So there's no more fat across the top. There's no more bone. That's all been eliminated, and that's a 2-inch lip on. Red, and there we go. If we take that fat and just rip it off and lay the whole thing down, just lay it down flat, then that's called a rib eye roll. And then if we take that and just cut it into steaks, right, then that's called a ribeye steak. So here's what the issue is. Do we take this big chunk of meat right here, ka-chung, ka-chung, do we take this big chunk of meat and roast it in the oven and put a little bit of juice on it and serve prime rib, right? These are the prime ribs. Also, this is how you would buy prime rib. So it's just, do you want the bone or not? But it's still one big chunk of meat. So are we going to sell prime rib, or do we make more money selling ribeye steaks? And again, that what this chapter is about is we're going to incur all the cost to break this animal down to get to the point where we have the 103, 109, or the 2-inch lip on, whatever we buy for prime rib, right? Is this going to right? So now we have this prime rib. Or do we pay the butcher to go ahead and take the bone and the fat off and cut this into steaks and then make ribeyes? And that's what we have to decide, because it makes a difference in our cost. Where do we make the most money? And if we make the most money on a ribeye steak, then what we're going to do is price our steak accordingly so that people think it's a better deal, perceive it as a better deal, and the more steaks they buy, the more money we make. If we make more money on the prime rib, then we're going to do things like have a ladies cut, we'll have a men's cut, we'll have a regular cut, we'll have a child's cut. I mean, we'll have all these different cuts because we want to encourage people to order prime rib because it makes us more money. All right, I hope this was helpful, and this is just another attempt to try and get the videos to you. All right, see ya.